Programming is the process of creating a set of logical instructions for a digital device to follow using a programming language. The process of programming is sometimes called coding because the syntax of a programming language is not in a form that everyone can understand. The first development methodology we are going to review is the Systems Development Lifecycle, or SDLC. This methodology was first developed in the 1960s to manage the large software projects associated with corporate systems running on mainframes. Various definitions of the SDLC methodology exist, but most contain the following phases. Preliminary analysis. In this phase, a review is done of the request. This step is important in determining if the project should even get started. System analysis. In this phase, one or more system analysts work with different stakeholders groups to determine the specific requirements for the new system. System design. In this phase, a designer takes the system requirements document created in the previous phase and develops the specific technical details required for the system. Programming. The result of this phase is an initial working program that meets the requirements laid out in the system analysis phase and the design developed in the system design phase. Testing. In the testing phase, the software program developed in the previous phase is put through a series of structured tests. Implementation. Once the new system is developed and tested, it has to be implemented in the organization. This phase includes the training the users, providing documentation and conversion from any previous system to the new system. Maintenance. This is the final phase that takes place once the implementation phase is complete. In this phase, the system has structured support process in place. The SDLC methodology is sometimes referred to as the waterfall methodology to represent how each step is a separate part of the process. Only when one step is completed can another step begin. After each step, an organization must decide whether to move to the next step or not. This methodology has been criticized for being quite rigid. Good day everyone, I'm Angela Magnaya from BSCS 3A and I'm here to discuss something about the rapid application development. And here are the main agendas for this presentation. The first one is rapid application development definition and the second one is the 4 phases of rapid application development methodologies. Rapid application development. Rapid application development is a software development methodology that focuses on quickly building a working model of the software, getting feedback from users, and then using that feedback to update the working model. After several iterations of development, a final version is developed and implemented. The further explanations for this rapid application development is on the next slide. Rapid application development is a development model that prioritizes rapid prototyping and quick feedback over long drawn-out development and testing cycles. With rapid application development, developers can make multiple iterations and updates to a software rapidly without needing to start a development schedule from scratch each time. Rapid application development came to existence once developers realized the traditional waterfall model of development wasn't very effective. Rapid application development was conceived in the 1980s, so it's definitely not something new. But unlike the waterfall model, it's not singular. It is a continuous evolution of development philosophies according to the requirements at that particular time. The 4 phases of rapid action development methodology. The first one, requirements planning. The second one, user design. The third one, construction. And the fourth one is cut over. Requirements planning. This phase is similar to the preliminary analysis, system analysis, and design phases of the SDLC. In this phase, the overall requirements for the system are defined, a team is identified, and feasibility is determined. So, self-explanatory, sa requirements planning nagaganap lahat ng pagpaplano, research, at lahat ng mga kailangan para makabuo ng isang development software. User design. In this phase, representatives of the users work with the system analysts, designers, and programmers to interactively create the design of a system. One technique for working with all these various stakeholders are the so-called JAD session. JAD is an acronym for Joint Application Development. A JAD session gets all the stakeholders together to have a structured discussion about the design of the system. Application developers are also sit on this meeting to observe, trying to understand the essence of the requirements. So, dito po sa user design nagaganap ang lahat ng pagpaplano kung paano o ano ang magiging itsura ng isang system upang mas madaling malaman o maintindihan ng users kung paano ba dinevelop ang system para sa kanila. Construction. In the construction phase, the application developers working with the users are building the next version of the system. This is an interactive process and changes can be made as developers are working on the program. This step is executed in parallel with the user design step in an iterative fashion until an acceptable version of the product is developed. So, sa construction phase po, nagaganap yung collaboration ng application developers and the users para po makabuo ng gusto nilang system. Pwede pong pagsabay ng paggagawa ng construction at user design hanggang sa makabuo po sila ng system na gusto ng client. Cutover. In this step, which is similar to the implementation step of the SDLC, the system goes live. All steps required to move from the previous state to the use of the new system are completed here. So, sa cutover po nagaganap yung pagko-complete o compilation ng lahat ng ginawa mula requirements planning hanggang sa cutover po. Dito po minumove lang programmers, application developers at ng user yung nabuo na ng system para po magamit na po ng client nila. As you can see, the rapid application development methodology is much more compressed than the SDLC. Many of the SDLC steps are combined and is more focused on the user participation and iteration. This methodology is much better suited for smaller projects than SDLC and has the added advantage of giving users the ability to provide feedback throughout the process. SDLC requires more documentation and attention to detail and is well suited to large, resource-intensive projects. Rapid application development makes more sense for smaller projects and that are less resource intensive and needed to be developed quickly. Benefits of rapid application development: quicker delivery, quicker adjustments, fewer error, lower development costs, lower maintenance costs, faster release of versions, better adoption of new technologies, more involvement from business, more usable software, better risk control, happier clients, less chance of catastrophe, and better integrations.
Good morning, sir. My name is Mielaine Bolea and I'm going to report about Agile methodologies and Lean methodology. Agile methodologies are a group of methodologies that utilize incremental changes with a focus on quality and attention to detail. Each increment is released in a specified period of time called a time box. creating a regular release schedule with very specific objectives. While considered a separate methodology from RAD, they share some of the same principles: iterative development, user interaction, ability to change. The Agile methodologies are based on the Agile Manifesto, first released in 2001. The characteristics of Agile methods include small cross-functional teams that include development team members and users, daily status meetings to discuss the current state of the project, short time frame increments from days to 1 or 2 weeks for each change to be completed. At the end of each iteration, a working project is completed to demonstrate to the stakeholders. Lean methodology. In this methodology, the focus is on taking an initial idea and developing a minimum viable product (MVP). The MVP is a working software application with just enough functionality to demonstrate the idea behind the project. Once the MVP is developed, it is given to potential users for review. Feedback on the MVP is generated in two forms. First one is direct observation and discussion with the users. The second one is usage statistics gathered from the software itself. Using these two forms of feedback, the team determines whether they should continue in the same direction or rethink the core idea behind the project, change the functions, and create a new MVP. Sidebar: the quality triangle. When developing software or any sort of product or service, there exists a tension between the developers and the different stakeholders groups, such as management, users, and investors. This tension relates to how quickly the software can be developed, time, how much money will be spent, cost, and how well it will be built, quality. The quality triangle is a simple concept. It states that for any product or service being developed, you can only address two of the following: time, cost, and quality. So what does it mean that you can only address two of the three? It means that you cannot complete a low-cost, high-quality project in a small amount of time. However, if you are willing or able to spend a lot of money, then a project can be completed quickly with high-quality results through hiring more good programmers. If a project's completion date is not a priority, then it can be completed at a lower cost with higher quality results.
What is programming languages? A programming languages is a vocabulary and set of grammatical rules for instructing a computer or a computing device to perform a specific task. In other words, programming languages is a tool we use to encode informations and to create a software. Generational programming languages. There are 4 generations of programming languages. To begin with, the first generation of programming languages is called machine code. It is a programming languages that is done by directly setting actual ones and zeros. We need to use that is called binary codes. In addition, we have the second generation, which is called the assembly language, which gives English-like instruction. It is a program that must be run through an assembler or application to distinct the machine code. Moreover, the third generation are not specific type of hardware on which they run are more like spoken language. Example: BASIC, C, Pascal, and Java. Lastly, the fourth generation are class of programming tools that enables fast application development using intuitive interfaces and environments. Example: Clipper, Focus, FoxPro, and SQL.
Versus interpreted. Besides classifying a program language based on its generation, it can also be classified by whether it is compiled or interpreted. As we have learned, a computer language is written in a human-readable form. In a compiled language, the program code is translated into a machine-readable form called an executable that can be run on the hardware. Some well-known compiled languages include C, C++, and COBOL. An interpreted language is one that requires a runtime program to be installed in order to execute. This runtime program then interprets the program code line by line and runs it. Interpreted languages are generally easier to work with but also are slower and require more system resources. Examples of popular interpreted languages include BASIC, PHP, Perl, and Python. The web languages of HTML and JavaScript would also be considered interpreted because they require a browser in order to run. The Java programming language is an interesting exception to this classification, as it is actually a hybrid of the two. A program written in Java is partially compiled to create a program that can be understood by the Java virtual machine. Each type of operating system has its own JVM which must be installed, which is what allows Java programs to run on many different types of operating systems. Procedural versus object-oriented. A procedural programming language is designed to allow a programmer to define a specific starting point for the program and then execute sequentially. All early programming languages work this way. As user interfaces became more interactive and graphical, it made sense for programming languages to evolve to allow the users to define the flow of the program. The object-oriented programming language is set up so that the programmer defines objects that can take certain action based on input from the user. In other words, a procedural program focuses on the sequence of activities to be performed. An object-oriented program focuses on the different items being manipulated. For example, in a human resources system, an employee object would be needed if the program needed to retrieve or set data regarding an employee. It would first create an employee object in the program and then set or retrieve the values needed. Every object has properties, which are descriptive fields associated with the object. In the example below, an employee object has the properties name, employee number, birth date, and date of hire. An object also has methods, which can take actions related to the object. In the example, there are two methods. The first is compute pay, which will return the current amount owed the employee. The second is list employees, which will retrieve a list of employees who report to this employee. What is COBOL, or Common Business Oriented Language? If you have been around business programming very long, you may have heard about the COBOL programming language. COBOL is a procedural, compiled language that at one time was the primary programming language for business applications. Invented in 1959 for use on large mainframe computers. COBOL is an abbreviation of Common Business Oriented Language. With the advent of more efficient programming languages, COBOL is now rarely seen outside of old, legacy applications.
Good morning, sir. My report is about sidebar what is COBOL. COBOL is procedural, compiled language that at one time has primary programming language for business application. Invented in 1959 for use on large mainframe computers, COBOL is an abbreviation of Common Business Oriented Language. With the advent of more efficient programming languages, COBOL is now rarely seen outside of old legacy applications. Programming tools. To write a program, a programmer needs little more than a text editor and a good idea. However, to be productive, he or she must be able to check the syntax of code and in some cases compile the code. To be more efficient at programming, additional tools such as an integrated development environment or computer-aided software engineering tools can be used. An ED provides a variety of tools for programmer and usually includes an editor for writing the program that will color code or highlight keywords from the programming language. A help system that gives details documentation regarding the programming language. A compiler or interpreter will allow the programmer to run the program. A debugging tool which will provide the programmer details about the execution of program in order to resolve problems in the code, and a check in check out mechanism will allow for team of programmers to work together on a project and not write over each other code changes. Probably the most popular ED software package right now is Microsoft Visual Studio. Visual Studio is the ED for Microsoft programming languages including Visual Basic, Visual C++, and Visual C#. Case tools. An ED provides several tools to assist the programmer in writing the program. The code is to be written. Computer-aided software engineering tools allow a designer to develop software with little or no programming instead. The case tools write the code for designer. Case tools come in many varieties, but their goal is to generate quality code based on input created by the designer.
Good morning, sir. Good morning, classmate. My report is all about sidebar building a website. So, in the early stage of World Wide Web, the creation of website required knowing how to use hypertext markup language, in short HTML. Today, most websites are built with a variety of tools, but the final product that is transmitted to browser is still HTML. So, HTML, it's simple, is a text language. So, HTML daw po ang kadalasang ginagamit kapag gumagawa po ng website. Ito po yung kumbaga pinakamadaling code para makabuild ng isang website. The different components of web page, these definitions are handled through the use of HTML tags. So, ang example po niyan itong simple HTML. Andito po yung less than H1, greater than. This is a first level heading. Less than slash H1, then greater than. So, yun ginagamit po yung H1 para po sa heading po yun. Then, may break po siya na slash H1. Then, H2, yung H2, it means heading number 2 or second heading. Here is a second level heading. Then, here's some more text. Yun po. So, ang huli ko pong topic ay build versus buy. So, when an organization decide that a new software program needs to be developed, they must be determined it makes more sense to build and themselves or to purchase it from outside company. So, mas okay daw po yung gumawa ng sariling website kesa po yung bibili sa outside company. So, bakit po? Kasi po, kapag bumibili po halimbawa sa ibang company, nalalaman din po nung iba kung ano po yung ginawa nyong website. Kumbaga ano po yung mga code. Syempre, binili nyo lang po yung kumbaga hindi nyo rin naman syempre mapagkakatiwalaan yung binilan nyo kung hindi nyo po ilalabas yun or what. So, may advantage din naman daw ang pagbili ng software. First is, generally less expensive to purchase a software package than to build it. So, mas mura daw po yung bumili kesa gumawa. Second, when a software package is purchased, it is available much more quickly than if package is built in-house. So, gawa na po siya, hindi na po kayo mahihirapan, kumbaga hindi na kayo mag-iisip kung ano pong ano nyo, si Yung pinagbilan nyo na lang po ng programmer ang bahala mag-isip kung paano po yung gagawin niya. Kayo lang po ay yung magbibigay ng design, ganun. Software application can take months or years to build. So matagal-tagal din po pala yun na mga months or years din bago mabuo yung isang software application. Then meron din po tayong disadvantage sa pagbili ng software. Ito nga po yung sinasabi ko kanina. The software you are using can be used by your competitors. Ayun po. Siyempre po, pag bumili po kayo sa labas, ay malalaman po ng iba. Kumbaga, pag nalaman po nila, maaari po nilang gamitin yun or gayahin yung sarili nyong design or design ng kumpanya nyo. So, if a company is trying to differentiate itself based on business process that is in that purchase software, it will be a hard time doing so if competitors use the same software. Yun po, baka po magkaparehas pa. Another disadvantage to purchasing software is the price of customization. If you purchase a software package from vendor and it customize it, you will have to manage those customization every time the vendor provides an upgrade. This can become administrative headache to say the least. So ayun po, every update maabala po kayo kung mag-iisip pa po kayo ng bagong design or what na pag in-update po ng software. So dun lang po yung topic ko. Thank you po, sir and classmates sa pakikinig.
Magandang araw sa inyo lahat. Ako nga po pala si Junjun Ribanleanes from Group 2, and ang nakasign sa aking topic ngayon is all about web services and user computing. So let's start. Web services. As we saw in Chapter 3, the move to cloud computing has allowed software to be looked at a service. One option companies have these days is to license functions provided by the other companies instead of writing the code themselves. These are called web services, and they can greatly simplify the addition of functionality to a website. For example, suppose a company wishes to provide a map showing the location of someone who has called their support line. By utilizing Google Maps API web services, they can build a Google map right into their application. Or a shoe company could make it easier for its retailers to sell shoes online by providing a shoe size web service that the retailers could embed right into their website. It can blur the lines between build versus buy. Companies can choose to build a software application themselves, but then purchase functionality from vendors to supplement their system. Web services. A web service is a software service used to communicate between two devices on a network. More specifically, a web service is a software application with a standardized way of providing interoperability between disparate applications. It does so over HTTP using technologies such as XML, SOAP, WSDL, and UDDI. So for the term itself, web services, it is a way to share data between two separate systems. It works by having a client and a server, where the client makes some requests for some data and the server responds to it. And that's how communication of data is taken place into it. And user computing. In many organizations, application development is not limited to the programmers and analysts in the information technology department. Especially in larger organizations, other departments develop their own department-specific applications. The people who build this are not necessarily trained in programming or application development, but they tend to be adept with computers. A person, for example, who is skilled in a particular software package, such as a spreadsheet or a database package, may be called upon to build smaller applications for use by his or her own department. This phenomenon is referred to as end-user development or end-user computing. End-user computing can have many advantages for an organization. First, it brings the development of applications closer to those who will use them, because IT departments are sometimes quite backlogged. It also provides a means to have software created more quickly. Many organizations encourage end-user computing to reduce the strain on the IT department. So lastly, we have the end-user computing. In its most strict sense, end-user computing, or EUC, refers to computer systems and platforms that help non-programmers create their applications. So from the meaning itself, it describes a series of computer systems and platforms that allow non-programmers to create working computer applications to better manage the needs of both employees and the organization.
Sidebar: building a mobile app. Building an application for a mobile device is exactly the same as building an application for a traditional computer. Understanding the requirements for the application, designing the interface, working with users, all of these steps still need to be carried out. An application running on the mobile device must be designed to be functional on a similar screen. Mobile application should be designed to use fingers as the primary pointing device. Mobile device generally have less available memory, storage space, and processing power. Mobile application also have many advantages over application built for traditional computers. Mobile application have access the functionality of the mobile device, which usually includes features such as geolocation data, messaging, the camera, and even a gyroscope. A mobile app is an expensive proposition, and it will only run on one type of mobile device at a time. For example, if you create an iPhone app, users with Android phone are out of luck. Each app takes several thousands dollars to create, so this may not be best use for your funds. Implementation methodologies. Once a new system is developed or purchased, the organization must determine the best method for implementing it. Convincing a group of people to learn and use a system can be a very difficult process. Using new software and business processes it gives rise to can have far-reaching effects within the organization. There are several different methodologies an organization can adopt to implement a new system. Four of the most popular are listed below. The direct cutover. The direct cutover implementation methodology, the organization selects a particular date that the old system is not going to be used anymore. On that date, the users begin using the new system and the old system is unavailable. The advantage to using this methodology are that it is very fast and less expensive. However, this method is the risky as well. If the new system has an operational problem, or if the users are not properly prepared, it could be proved disastrous for the organization. The pilot implementation. In this method, a subset of organization called a pilot group starts using the new system before the rest of the organization. This is a smaller impact on the company and allows the support team to focus on the smaller groups of individuals. The parallel operation. With parallel operation, the old and new system are used simultaneously for a limited period of time. This method is less risky because the old system is still being used while the new system is essentially being tested. However, this is by far the most expensive methodology since work is duplicated and support is needed for both systems in full. The phase implementation. In phase implementation, different functions of the new application are used as functions from the old system are turned off. This approach allows an organization to slow move from one system to another.
Good day, sir. I'm going to report change management. Change management. As new systems are brought online and old systems are phased out, it becomes important to manage the way change is implemented in the organization. Change should never be introduced in a vacuum. The organization should be sure to communicate proposed changes before they happen and plan to minimize the impact of the change that will occur after implementation. Change management is a critical component of IT oversight. Maintenance. Once a new system has been introduced, it enters the maintenance phase. In this phase, the system is in production and is being used by the organization. While the system is no longer actively being developed, change need to be made when bugs are found or new features are requested. During the maintenance phase, IT management must ensure that the system continues to stay aligned with business priorities and continues to run well. Dahil marami ng pagbabago sa teknolohiya, kailangan makipagsabayan ang bawat kumpanya at organisasyon. Ngunit hindi dapat basta-basta at madaliin. Kailangan masusing pag-aralan paano sasabihin at isasagawa ang pagbabago, lalo na sa mga nakasanayang sistema sa loob ng organisasyon. Hindi dapat biglaan dahil pwedeng malagay sa alanganin. Sa halip ay makapagdudulot ng kadalian ng trabaho. At para naman sa maintenance, ito naman ang pangalawang proseso matapos magtagumpay na ituro at palitan ng bago ang lumang proseso at sistema. Kailangan pa rin patuloy-tuloy ang tabayanan at siguraduhin na di magkakaproblema ang sistema. Yun lamang po, maraming salamat.